So today's researcher is Mr. Suman Gomosta from Indian Institute of Technology, Madras, who is going to be talking about boron chemistry.
How this boron chemistry came into the research, particularly application-wise, academic-wise, what is the major part, how come into the picture, and followed by I will discuss what kind of experimental things need to be for synthesizing those kind of molecules, and what are the difficulties and why not can we synthesize those kind of molecule and their application. As well as H.C. Brown got a Nobel Prize in 1979 because of development of hydroboration reaction. So this hydroboration reaction I will tell you little bit elaborately on my next slides. But unfortunately it was not implemented because when they tried this pentaboron 9 molecule as a fuel in the rocket engine and jets, they found that when this molecule is combustion taking place, they are generating so many toxic fragments, organic fragments, as well as this pentaboron 9 molecule having the nature when it is coming to the contact with the air, it is flammable. Reaction, they started using the boron basically as an inhibitor. So based on electron calculation, you can categorize the clusters in the geometries. Mostly closo, nito, and arachno clusters can be synthesized in the laboratory, but this hypo and plateau is very rare and it is very difficult to synthesize because ACP came as a 13. So N+1 category it is. So N+1 category means it is a closure structure. Show up each of the vertices, so it will generate the trigonal phase. So how many trigonal phase it will generate? Total 4 trigonal phase it will generate. And as well as in that movement, it will generate 4 hexagonal phases. 10D is a non-radioactive, so it has the characteristic to capture the neutron. So what they are doing basically, this BNCT therapy basically used for the cancer research, cancer treatment, tumor treatment. Thinking that this amine boron attack, it is a basically 𝐒𝒏𝒂𝒏 attack, which can be useful as a fuel. Some molecule which is having the pi conjugation and extended sheet kind of things, where the pi, due to the pi interaction and the intermolecular charge transfer, that molecule become the fluorescent. First of all, which is this kind of complex synthesizing is a very challenging in the sense, I'll tell. First, when you are thinking one reaction, you have to think which kind of metal I will take first, then which kind of boron containing ligand I have to synthesize. Before synthesizing that ligand also, you have to choose some good donor kind of organic moiety. So as sigma donation, two sigma donation happen to the metal center, it is called as a p sigma boron. And another category has been introduced that is called the agnostic sigma boron video, where you can see how we are generating the inert atmosphere for the putting the reaction, and there are others synthesizing those kind of things is available. That front one is the vacuum, behind one the argon. So if you change the knob, you can see you can connect with the argon line and as well as the argon line. So now it is done. It is in argon atmosphere there. So now you can open inside one. So now it is not contaminated with the air sides. So it is fully in an inert atmosphere basically. Now I am taking out my everything and again closing it. Same coordination mode with silver center and BH interaction they are present. Means what is the reason? So basically the PPH3 that attached with the phosphorus, that phenyl ring is a basically planar, but cyclohexyl ring it is not a planar. It will continuously propagate and give the chair and board form in structure. So that's why it is a bulky group basically, which is attached to the phosphorus. One of my colleague in IIT Madras, so I went to them and explained, can you tell me this, why it is happening? Because he is a NMR specialist. So he helped me. He told, you are recording basically phosphorus NMR, and this phosphorus attached with the silver center. So silver having basically 2 isotopes, one is 107 and another is 109. both are basically abundance, naturally abundance is equal. Exactly this doublet of doublet is coming. And finally, I will thank my supervisor, Professor Sundar Gopal Ghosh. I'm very much fortunate to work with him and learn boron chemistry, how to perform as a researcher, how to solve the problem also. And here is our one lab group photo, which has been taken in front of our new admin building. And finally, I would like to acknowledge my parents, family members, and friends.
Like boron is a metalloid, right? Like it is not a metal, not a non-metal. It is a metalloid, right?
Yes, yes.
So, like, can we tell about its conductivity, like whether it is a semiconductor or like that?
Yeah, that is a very nice question, because basically when you people are making the semiconductor device, those things, they need the band gap basically. I don't know much about that semiconductor, though I'm not from the physics background, but whatever I know, people are thinking to make, people are trying to accumulate some kind of arrangement and making the band gap more or lower so that semiconductor having the more performance can show. So boron has been used as a doping for the making the semiconductor as a boron atom, or people are using boric acid from their means incorporating boron atom into the sheets or some combination. Like whoever doing the solid state chemistry basically means as a material scientist, they are combining molybdenum, sulfur, molybdenum sheet, they are doping upon the nitrogen, so it will give their performance more high. So boron can be also used as not a semiconductor can be used, but you need some other fragment also to make the electron donation acceptance combination.
Why argon and not other inert gases?
Okay, this is also one very good question I will tell, because why argon we are using. First of all, nitrogen also an inert gas. Nitrogen people are not using because nitrogen having when you buy one cylinder from the vendor or outside of the company, that nitrogen is written will be the 99 point something % of purity, but it is not, because nitrogen having the nitrogen gas cylinder having containing the oxygen also. Mainly this boron chemistry people are using argon cylinder because the oxygen contamination on the argon cylinder is very much less. It is a 99.99% pure. Okay, but if you use the nitrogen, you cannot do, because that oxygen will interfere in your reaction. It will directly react with your molecule or reagent when you are putting the reaction. That time problem will arise basically. So that's why argon people are using mostly. Last 4.5 years, I am working in a boron chemistry, and there is so many things will appear, challenge will appear, accept the challenge and resolve the problems. So if you want to do research, don't be always like no, it is not happening. If problem will not face you, then how you can do the research basically. So problem will appear in your face and you have to solve and you have to go through that. And exceptionally, I would like to thank this research on web to share my things also here in my experience. Thank you.
We are launching our India's first solely dedicated research platform where your work will be showcased. That is called www.researcheronweb.com. It's an official site for all of your researchers so that you can share your articles, your research work, your publications in the form of blogs, or you come and give a live webinar session on the topic you have been working with.